Hello everyone, welcome back to Power System ECE360 Lecture 10 Part 2. In this lecture we're going to talk about bundle and stranded conductor and how to find GMD and GMR for those, right? So how to find GMR and GMD for bundle conductor. Let's over here, this conductor over here, this side we have X, this side is Y. So this conductor has this many strand over here, and this conductor has this many strand over here, right? So what is the GMD between them, and also what is GMR for this conductor? GMR stands for the conductor itself, right? GMR, and GMD is between the conductors. So GMD is between the conductor, right? GMR is for the conductor itself, and GMD is between the conductor. And each of these conductor could be stranded by itself. Look at this. The conductor could be stranded right here. As you know that your CR or other conductor have a strand and reinforcement inside. So each of the conductor could be stranded by itself. So each of the conductor could have their own GMR also. So let's see how to decode this thing. So let's see. This is the bundle over here. This is the bundle. So bundle has different conductor, and each of the conductor itself can be also stranded like that, right? So stranded conductor and bundle conductor, and your bundle could be as high as this many over here. I see that the 8 of them over here is maybe 1,000 kilovolts line. They have 8 of them in there. So each of the conductor itself look like this. So they have a stranded conductors. There's an aluminum conductor out here and steel reinforced inside it. Okay. Now let's decode this. If you remember, your L is the equation for L was 2 times 10 to the negative 7 is developed in last time, ln GMD over GMR, right? That's the and it's handy for meter. So this is the equation for inductance per line. So I have two line X and line Y. If I'm looking for inductance for line X, so I need the GMR for line X, and I need the GMD between them. So let's do that over here. So now I'm looking for line X over here. So this is the common thing. So I need the GMD. GMD means between the line, right? So I have to have, let's start A with A prime, A with B prime, A with C prime, and all the way to A with M, right? That's for A. Then if I do B with B prime over here, B with A prime over here, B with C prime, and B with D prime. So look at that. GMD is between the line. So if I do that, this one has M number of conductor, this is M number of conductor. If I multiply them, I have Mn number of conductor. So I have to take the Mnth root of the all distance to make the geometric meaning there. Okay. So that's the GMD. This is your GMD. This is between the conductors, right? Now it's between the line. Now we have this conductor over here. I have the GMR. So GMR in the conductor, right? GMR for the conductor and GMD between the line, right? GMD between the line. So over here, look at that. I have A, the self, remember, self resistance or self radius. Sorry, self radius, not resistance, self radius. DAA, DAB, right? And D and all others, right? Look at here. So I have N numbers, right? So I have, for each of them, I have N number of distance or quantity. Then I have N number of them, so I have N squared over here to find the geometric mean. So this is the GMR. This is the GMR. And again, GMR for the east line, all right? East conductor, right? So now GMR, GMD right here is handy per meter. And so DAA, DBB, all the same. There should be RX prime because that's the, what do you call it, DS, geometric self radius, right? So that all here. So GMD over GMR. And you should be able to find expression for LY. It's up to you. I'll leave it up to you to find the expression for LY. And now try to find the GMR of a stranded conductor. I have a single conductor. There are 7 strands in there, right? How to find the GMR over there? So remember that GMR is conductor need to be take the distance from all others, right? So if I look at the conductor 1 here, it has distance from 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7. I have to compare all those distance, right? Then if I go for conductor 2, it has same thing. Self one, they have the first self one there, which is R prime. This is the R radius for each the strand. So for conductor 1, I have this, right? I have this component here, R prime, which is the self geometric mean radius for the strand 1. Then I have distance is D12, D13, D14, D15, D16, D17. Look at that. 1, 2, 3, 4, 5, 6, 7 of them, right? If I do the conductor 2, I'll get 7. If I do conductor 3, I'll get 7. If I do all 7, I'll get 59 quantities. 59 distance quantity, right? Right. So for the root, for the geometry mean, I need 59, 59th root of this element. So now over here, you can see that D13 is equal to D15 is equal to D35. They're all same distance. 13, 15, and 135. Right, they're all the same distance, right? You can see that they're all three same distance. These distance are, if you look at the math there, distance would be 2r squared minus r squared. It's just simple geometry in there. That will give you 2 square root of 3r, right? That's a d. And then other one, d12 equal to d16 equal to d17 is 2r, right? And d14 equal to 4r, right? This is the distance, right? So now, if I do the math over here, you can see that for all 6 conductor outside, they have the same distance formula, right? 1, 2, 3, 4, 5, 6. They have the all same distance, right? And the 7 has the different distance quantity, right? So if I try to find the GMR for this one here, I need to go in here. I need, you know, that it's 49, 7 square here. Then all 6 of them, this one, this one, this one, this one, this one, the same thing, right? So I can just take one and put them and power 6, right? So that would be 2r, one distance from here. And then I have another 2r, this all here, 3 of them, right? Right, then I have 3 of these, right? 2 times square root of 3r, 2 times square root of 3r, 2 times square root of 3r. Then I have one more is 2r, which is d14, right? So is 4r actually, 4r, right? Then I have the self one, which is r prime, right? So I can say that this is the 6 of them there. So I have 7 distance there. I should have, there are 2 of them, so not 3 of them, there are 2 of them here. Sorry, I made one more here. So there should be, what? So that is 4r, r head, r prime, 6. Then for the middle one, 7, all other distance is 2r. So that you have r head and 2r, there are 6 of them. Right, so now look at that. There's 49 inside, and if you do the GMR here for this one, you will see that your results will come 2.176R. So that is your GMR for this particular example. So now see how the GMR here, you find the distance between each other and take the geometric mean of all of them. All right, so now I'm gonna do a quick example over here for you, like this one here. So now GMR for these 2 conductor over here, GMR between in one, it's one phase you have 2 conductor there. So 2 conductor, you have distance self ds right here. It will be given by your manufacturer. Then distance between them in d, and if you do this one also, same ds and distance between them too. So you have 2 of them here, and there are 4 quantity. Then you take the 4th root. That's the, so that if you do that math over here, it should come down to let's see, it would be like this, right? DSD, right? Then if you have three conductor here, so this one, all of them have the same DS, self geometric mean radius, DS. So DS and 2D over here, so that and three of them same to root here, and the ninth quantity, ninth root over here. So if you take the distance over there, it will be 3 ds d square, right? And a four conductor, again, let's try to do this on four conductor over here. So you have you have a 16 quantity in there. So each of them has ds, right? And you have to find this guy over here. That this is a hypotenuse of that triangle should be square root of 2d, right? So you have d and square root of 2d, right? And there are four quantity there. Then you have all four of them have the same one, so you have fourth power there. Then if you do dsb, b for the bundle here, you will get 1.094 ds dq, right? So now you know how to find GMR for the bundle conductor. Let's go back to this one here. Let me share one of this mention. So when you this is the conductor, right? This GMR I find the conductor is called. This is basically you're finding self geometric mean. This is basically DS for each conductor, and that is given by your manufacturer. All right. So now if you try to do this one here, let's assume that all the distance you know from here, all the distance you know, so all of them have the same distance, right? If it doesn't matter which you're taking, all of them have the same distance. So if your D1, let's say it's your D1, 2, or let's make it D1 to make it simpler. So D1, D2, D3, D4, D5, D6, D7. There are 7 of them, right? So we have 49th root. Then you can easily find GMR for this bundle here. That we call it DSB, right? You know that is a 49 of them, right? Then each of them, every one of them will have the same distance. So we have a let's say DS over here for the self one. Then we'll have D1, D2, D3, D4, D5, D6, D7, right? Oh, no, 6, only 6, not 7, only 6. So that that will give you 7 of them. We'll have 7 over here. That's your DSB for this bundle over here. I hope that you have got an idea for how to find the GMR for the bundle conductor, and also how to find GMR for a particular conductor. That's all for this video. We're gonna see you in the next video how to put this together, right?